speed the data is coming. So how much data we receive in a day. Am I not audible to anyone? Can you please confirm? Okay.
Yes, Snigdha, you are audible.
Someone in the chat session are telling that I am not audible, so I just wanted to confirm. Yeah. So velocity is the speed at which we are receiving the data, and then come the second V, that is the volume of data, that is a quantity of data. As I said, when it reaches the threshold of terabytes or petabytes, then we consider it as a big data. The other V is value. Like after getting some insights, like how much value is it adding to a particular organization. So that is one more characteristic of big data. And the other is variety of data, which includes the data might be structured or unstructured. In a way, we can tell if you have knowledge about rdbms, it is a structured data. And coming to unstructured data, it is like any messaging queues or systems will produce a data in the form of messages that is not unstructured. So like this variety kind of data might be available. There are so much data generated every day in social media, which the format is not predefined, right? So those all structured, semi-structured and unstructured data, these are the varieties of data which can be big data. And the veracity is the goodness of data. Like, is the data messy or is it good for analysis? If it is messy, we try to clean the data and then use for our processing, and which can be used for analytics. So these are pretty much 5 V's where we can say that this can be a big data if it is having these 5 characteristics. Is anybody having any questions on this? Are you clear about what a big data is till now? If you have any queries or concerns related to this topic, you can put it on the chat. Veracity is the goodness of data. Like, is the data having proper data which can be used for analytics purpose, or if it is having any null values or skewness of data. Like if it is having proper data, or it might have some special characters which cannot be used for analytics, right? So that is the veracity. Are you clear, Manisharan? And then variety is like there are 3 kinds of data which is structured. Like data is stored in a table, particularly when we consider an employee data, it is all stored in a particular table in a rdbms. So it has the employee id, employee name, employee salary, department, all these are stored in particular rows and columns in a table. That is a structured data. And coming to other varieties of data, there can be semi-structured data, like which data is produced by particular messaging queues or messaging systems that is not stored, or it doesn't have any schema, or it doesn't have any column names, particular labels are not mentioned. That can be any data, that can be of text, that can be of any paragraphs or text files, which is not having any particular format. That is semi-structured. And there can be any other data like in the form of images or some audios or videos, that can also happen. So these are the 3 varieties of data. Is that clear, Dinesh? Yeah. So let's continue to the next slide. So before getting into big data, like why this big data actually came into picture, there are many rdbms systems, right? So what is the difference, like why the big data word suddenly came into picture apart from the traditional databases and all? So this is the reason why. So traditional databases, let us consider an example of an ATM machine. Like as a user, you are going to ATM, then doing some transaction, you are checking your balance or withdrawing the money, like that. So that will be stored in your account under your name in particular table in the rdbms. So like that, each and every user activity will be stored in an rdbms, which can be used for tracking purposes or recording purposes from an organization perspective of view. Then why suddenly this big data and analytics systems came into picture? So if we perform some reporting on the data which is available in rdbms, then that might hamper or that might, when you're trying to check your balance, if this reporting kind of job is running on that particular database, then that might hamper the performance of the system, because this analytics needs to join so many views in that so many tables present in the database, that might hamper its regular activity or the purpose for which it is created. So that is why for analytics, some different kind of environment is required, and analytics required past data as well, not only the current data. It might require some 20 years data to analyze the complete progress of an organization and the user demographics, right? So that huge amount of data cannot be stored in an rdbms. That is one more reason why we go for analytic systems, and Hadoop is the best solution for this. So as I said you, these rdbms, which are mainly the monolithic systems, that means it is a single powerful machine. It has a few, like very good amount of data and resources, but as the data increases month by month or week by week, after some point of time, that would reach the threshold, and like doing analytics or reporting kind of work on such single machine may cost you more than which is required. So that is not fruitful, right? What we are doing is like that should be optimal enough. So that is why we go for a distributed system. So distributed system is pretty much a group of machines led by a master node. So if you have a knowledge of a cluster and node, what actually they are. So think like distributed system is a group of these common machines which we use in our daily life, and it is a group of such machines, and it will have, that group will have one lead machine which we call as master node, and the rest of the nodes will follow the instructions given by the master node. These slave nodes are the data nodes which has actual data and which process the data. So this huge amount of data will be divided among all the slave nodes, and each slave node will work on processing the data. So in this way, we can accommodate the huge amount of data, and we can do the work quickly, right? So that is the main agenda of distributed system. And whenever we design a big data system, we need to take care of three parameters. One is the huge storage, which we have, as we are add, we can add, like we have number of machines, right? So adding all those memories in each of the machine can provide a huge storage, obviously. And the parallel processing, so like each node is independent of the other node. Even if some node fails, the other nodes can keep on processing the data. So thereby we are increasing this parallel processing. One more thing is scalability. Like if we check this monolithic system, if we want to increase the resources, and if we want, as the data is growing, if we want to increase some parameters, up to some extent, we can give the extensions of RAM or memory or any other CPU cores. But after that, a monolithic system cannot accommodate these things. But when coming to the distributed system, we can add few more slave nodes so that it is easily scalable. So that is the main reason why we go for this distributed system. Yeah. And the next thing is like Hadoop, which is a big data framework. So what is this Hadoop and why is it so popular in big data? So this is the traditional big data framework. What is a big data framework? So there is like a problem how we can manage and process this huge amount of data, right? So in order to overcome the problems and which are not delivered by our traditional rdbms, then this Hadoop came into picture. Like what is the history of Hadoop is how it got emerged is there was first GFS and MapReduce. These are the two research papers which were released by Google. They have predicted the situation as the data increases, like how this can be managed and all. They have released few papers, Google people, under the name of GFS and MapReduce. And then Yahoo took these two papers and tried to implement the solution, like how to resolve or how to process this big data. Then the Hadoop version 1 came into picture. So in Hadoop 1, there are Google file system. So in Hadoop version 1, these people, Yahoo people, took this GFS and tried to implement the solution, working solution, and named it as HDFS, Hadoop Distributed File System. So from GFS paper, this HDFS component has emerged. And in Hadoop version 1, there was another component called MapReduce. This is the same implementation of Google's MapReduce research paper. And they created this HDFS and MapReduce as a Hadoop and released this version. So as the time passes, they discovered that like storage, as per the storage process, like HDFS is working fine, but for the processing and the resource management, all the functionality is embedded in the MapReduce. So there comes the issue, like MapReduce alone was not able to perform all the resource management as well as processing both. So in Hadoop version 2, they have come with new component called YAN, that is yet another resource negotiator. So MapReduce, which was previously performing both the resource management and processing, in Hadoop version 2, they have divided the functionality and created a new resource manager and named it as YAN. So in Hadoop version 2, there are three main components. This HDFS is for storage and MapReduce is for processing and YAN for resource negotiation. Is this clear? Hadoop architecture and the purpose of these components? Yeah, let's get to the next slide. So as a data engineer, what actually we do with the huge data that is present? So we try to, in simple terms, we will get the data from different sources. Yeah, YAN is the resource negotiator, which will give the processor like how much memory required to perform a job and how many CPU cores it requires to perform a job. So that processor will take the resources from the YAN and then try to perform it. Is that clear, Gulzar? Yeah. So now, as a data engineer, GFS is like Google file system. It is a research paper for a storage, distributed storage. It is kind of a memory storage implementation. They have done it based on GFS. Okay. Then, as a data engineer or big data developer, most of the time your day-to-day activities will revolve around these things. Like from source to target, you have to migrate the data. So the source can be present in different formats. Your source can be a simple transactional MySQL tables, or it can be few files which you get from the other third party rules, or you can get in API format, CSV format, some text files, or some files which are delimited with certain things, like it may have few data in that format. And after getting from source, we actually filter the data by using the Hadoop or any big data framework. Like there will be some ingestion framework which helps us to like take the data from different sources and put that into some HDFS, which we have talked right now. That is a distributed storage which can accommodate huge amount of data, as it is performed on a group of machines, which is a cluster, right? So example HDFS I gave, right, till now, that was a data lake in general. So the data lake which is used in a Hadoop framework is known as HDFS. Are you clear with the terms and technologies? Okay, then. So this is the generic process. So from ingesting the data to a data lake, now comes to the processing. So how do you ingestion framework example is like sqoop, or you can have some network gateway connectivity. Sqoop is mainly used for structured data ingestion, and Flume is for semi-structured data ingestion, or you may have Kafka as a messaging system, which can be a good streaming ingestion tool, or a queuing system. These are the few examples of ingestion framework. And data lake examples are like HDFS or Amazon S3. That will let you know the alternatives of all these things in the later slides. So just I'm trying to explain you the generic terms, what are included in a data pipeline. Yeah, I'll let you know. So first comes the database. You know what is a database, right? It is a simple rdbms thing. So coming to data lake, it is a distributed storage where we can exactly dump the data without cleaning or anything. It can accommodate every data, every kind of data. So that is the data lake. And data warehouse is somewhat specific in nature. We try to remove the unnecessary things, then try to load the data into data warehouse to do analytics, or we can use for storing the output of analytics which we get in data warehouse. So data mart is like specific to some department or some partition based on the business requirement. Each data mart will have, no, I'm not changing the slides. I'm just trying to answer one question raised by our audience. So a data mart is something specific to the data. Like if it is a data mart related to COVID analysis, only COVID kind of transaction will be stored in that data mart. So that is specific to the use case. Is it clear the difference between the data lake, data warehouse, and data mart? Nelson? Yeah. So next, so from source, we can ingest to the data lake, then process it, and then load either in the data warehouse or data mart, which can be used for the visualization team to get insights from it, and which can be used for a business process. And this processing can be of two types. One is the batch processing and other is the streaming processes. So batch processing is mainly depends on the historic data. So we can take some 20 years of data, collect it and wait till the data is gathered and then do the processing. Like it can be like on a weekly basis also we can do, on an hourly basis also we can do, or daily basis also we can do. So the data is processed in the form of batch. You don't process it instantly. The other type of processing is the streaming. So it is the real-time data processing which we do. That is done by Kafka. And batch processing is done by some other Hadoop or some other tools. Then finally, we can load the data according to the business use case, either in the warehouse or some NoSQL database, which can be used for the other downstream people, where they will perform this visualization, or Power BI team, we can say. They can create dashboards and represent this data analytics in a layman terms, and that can be used by an organization to gain insights from the data of the users. So are you clear about the agenda of a data pipeline and what a data engineer does with the big data? So many of you might have a thought, like if you know the ETL process, like what does an ETL developer do? What is different from a big data developer does? So here you can consider ETL as the subset of a data pipeline. So because in batch process is similar to the ETL work which they do, but here the difference is a big data developer must know a programming language also. That is the main difference, because here they use different kinds of programming languages to filter this data, unlike some tool based work. So ETL developer might use some tools which are specific and does this processing, the ETL processing. And you can consider like the output of a data engineer, which are the data sets. Those are the inputs of a data scientist. They take these data sets, we create or generate useful data sets which can be helpful for analytics purpose. So that is the main difference. Like data scientist is some kind of future prediction kind of work, but here we are just doing the or generating the useful data sets which are used for analytics purpose. So pretty much data pipeline will be like this, which I have just explained over words, like you can see here. Yeah, let me tell you here in this example. So these are the different data sources using some ingestion system based on if it is a streaming or batch. Based on that, some ingestion tool will be decided, and then the for processing that will be sent into some data lake, and from there the processing systems might take it, consume the data, and then do its transformations. So while this Databricks is completely a different concept, it is a lake house concept, which is a combination of warehouse and the data lake. And Spark Scala is like the processing units, which we say filtering the data or transforming the data. That includes Spark and Scala. Like in the previous slides, if you have observed, it has some process, right? Like here also in Hadoop, if we observe, MapReduce is there, right? So MapReduce is the processing component here. Similarly, it has few of the drawbacks. That is why Spark came into picture. It is just, Spark is just an equivalent component of this MapReduce. Are you clear, Mayank? So after generating the data sets, we will store into some NoSQL storage or some warehouse, which can be used by the visualization people and turn that data into insights. This is pretty much the journey of data from source to the insights form. This process is clear, right, for anyone? Do anyone have any questions till now? Yeah. So these are the alternative big data tools we have. Ingestion tools are like few of them ask the examples, right? So for each of the process, I have mentioned few alternative tools which we have discussed about the Hadoop, which is the traditional open source system which we have on prem. We have two solutions, like HDFS and NFS. HDFS is more like you can think as a distributed file system. So it is considered from a perspective of an entire cluster, but whereof NFS is like network file system, I guess. So it is on monolithic system or single system. So ingestion tools are like Sqoop, which is a Hadoop solution for ingestion. And similarly, AWS has one AWS Glue service, which acts as an ingestion solution. And similarly, Azure has Azure Data Factory. So now the expectation from industry is like to have any cloud knowledge, because most of the projects are being migrated to cloud nowadays. So it is first, as a data engineer, you must be clear of all these Hadoop components, which the ability to perform all these tasks, and then these are just an alternative solutions, and like it's just adding desserts to your lunch. First you should have basic lunch, right? Then you can add so many desserts which you like. So these are like just like that. So how many more components that will be adding to your profile? And the data lake options are like, for Hadoop it is HDFS, for AWS cloud it is Amazon S3, and then for Azure it is Azure Data Lake Store. And for processing we have a few solutions like MapReduce, Hive, and then Spark. So first comes the MapReduce, which was the basic component for processing. And later Hive is just like in MapReduce, people used to write the code in Java. Like for each simple process also there used to be a lot of lines of code which was in Java. It was pretty much difficult for data people to write it, because as a developer people can write it, but as a data person we mostly play with the data using SQL, right? So we thought like, why not we use SQL kind of query language for analytics purpose also, instead of writing so much lines of Java code. Then Hive came into picture, and it is just an abstraction over MapReduce, where we can submit our query in the form of SQL to Hive, and that will internally convert that query into MapReduce code, and then it perform or process the data. Later on, they also felt like MapReduce have few drawbacks, which is like it is consuming so much disk IOs, or which is cost effective. Like for every single processing, it is reading the data from the disk. For intermediate processing also, it is again putting back to disk, again reading from disk, again putting back to disk. So number of disk IOs to process the entire data was very high, and for that reason MapReduce was very low performant. Then they invented Spark, which is like in-memory compute engine. It computes everything in RAM only. It doesn't take for reading the data at first, it takes from the disk. All its computation it will do in the RAM, which is in memory, and then in RAM only it will try to process the data, and final output which we get, that it will store in the disk. So hereby we are overcoming the problems which were in MapReduce, Hive, and Spark code is like write one kind of code and then connect to many other tools which are available in the big data ecosystem. So it is a general purpose compute engine which does the performing or processing in memory. So that is why Spark is 100 times like faster than MapReduce. So that is why there is more hype created on Spark. This presentation, I'll let you know how can I share this. As a starter on data engineering, which stream can you advise to start with, that is on premise or AWS or Azure? So you can first try to start on some Cloudera, which is then like you can install it easily on your Windows laptop, as most of them will have a Windows laptop, as big data is a distributed environment kind of thing. It is hard to like what do you say, install everything on Windows, because it is basically a distributed environment thing on Linux systems. So you better use any other environment like Cloudera, which provides you such environment, like with at least one node of environment, so that you can start trying on premise. Then after learning every concept of Hadoop and how these things work, then you can go for AWS or Azure. So coming to processing, like we have discussed all these things, right? The difference between MapReduce, Hive, and Spark. Are you clear of each component's purpose? And then for AWS, there are alternate solutions for processing, that is Athena, Redshift, and on Azure, it is Synapse Analytics. So what is the purpose, or what is the requirement of NoSQL DB in the part of this data engineering? So whatever we get, the data sets generated from our data pipeline, sometimes we have these data pipelines or this data distributed analytics, distributed systems are good for analytics purpose, not for the transactional purposes. So for transactional purposes, it is good on a database only. So transactional purposes means what are the transactions we can perform. That is like to update some queries or update few of the records or delete few more records. So those are the transactional things. So that is not good for a analytics system, because analytics system should have the complete data. We cannot delete few of the data, or we cannot change few of the data. So for such transactional uses, they also prefer this NoSQL DB, which has both the like advantages of a distributed system and the transactional system. That is why they prefer this NoSQL DB. And if you have any queries related to big data, then I can take it up. So this is what I wanted to discuss with you all today for the session.
Before we start Q&A, just I put up a poll. Please provide your answers there.
Sorry.
I have started a poll. Please answer those questions. And now you can start with Q&A.
So can I stop sharing my screen?
Yeah, sure. So there are questions in the chat and Q&A also. Please do answer them.
Okay, then. So is SQL enough to process data? As I said, processing the data requires so many tables to get joined. So if we run such a complex query, that might bring down the actual transactional purpose of an SQL system. So that is why we required separate analytics system to process the data. I think this is clearing your doubt, Amit, right? So what are the basic skills required to get an entry-level data engineer role? So firstly, you should be very good at your SQL things because we play with data. So in any part of the data filtering process, you play with data and you need to check the data and analyze the data. So first thing is an SQL. Then you should know some functional language like Scala or PySpark, which is comfortable for you. And then you should get knowledge about this big data ecosystem, Hadoop fundamentals, big data fundamentals. Then you can go for a cloud. So mainly these are the 4 concepts which you have to study to get into big data role. So can you explain the concept of big data and machine learning? Okay. So big data is like in simple terms, it will generate the data sets which are required for machine learning. You can consider the output of big data is the input for machine learning to turn the data and grab the insights from the data. So firstly, you should be well acquainted with SQL, then learn any functional programming language like Scala or PySpark or Python. Then you should go for this big data fundamentals, which includes Hadoop ecosystem and different tools available. Then you can learn a cloud. So one must be prepared for DSA as well, like problem solving question for interviews purpose.
Can end the session here. Thanks a lot, everyone. And Snigdha, thank you very much for the session. It was very insightful. I hope everyone enjoyed it. There's another question in the chat. Just answer that, Snigdha, then we can
Okay.
end the session for all.
Okay. What is the stable version of Cloudera that we can start learning? Okay. So if you have any basic version of Cloudera, that would be fine. For specific components, we need like airflow. If you want to run airflow, then there would be some different specification. Like you can explore on Google, that will fetch you the correct version, because the different systems will have different versions. So I cannot suggest you the current version which it is like compatible. So in real time industry, all this pipeline which I have explained you, that will be either scheduled or automated using Airflow or some other scheduling tool. You just need to trigger that and it will perform all these things one by one in the form of task.
Thanks, Snigdha. Thanks, everyone, for joining in. The
Yeah.
And the session will be available on YouTube. The recording will be, so you can revise from there and watch anything you have doubt, you can clear from there. So thank you, everyone. Thank you, Snigdha.
Yeah, if anyone is having any other queries also, you can try to connect with me on LinkedIn. I can help you out in further queries. Yeah, thanks a lot, everyone.
Thank you. Thanks everyone. Bye bye.
Bye.